I like to think of it as the sun is made of everything that you're made of. So the sun is when it had the Big Bang, it threw out everything that actually constructed our solar system and the very fabric of life. And so we're really almost all made of stardust. The sun is predominantly hydrogen. There is helium and some other heavier ions in there. And the sun is very...
The sun, the core of our planetary group, is a small yellow star, a sweltering ball of gleaming gases. The sun, I like to consider it, is made of everything you're made of. When the sun formed during the Big Bang, it ejected all the material that built our solar system and the very fabric of life. Essentially, we are all made of stardust. The sun is predominantly hydrogen, with helium and a few other heavier particles mixed in. The sun is vital to us because it is, of course, a star. Let me tell you a little more about the solar wind, what it is and how it affects Earth. We live in the atmosphere of the sun. The corona, which you see during a solar eclipse, looks large but not enormous. However, this atmosphere is constantly streaming outward, reaching all the planets and extending to the edge of our solar system. In fact, it shapes our very place in space. While the solar wind influences satellites, the more damaging factors are the radiation and high-energy particles produced by the sun near the sun. The solar wind is particularly significant because it directly impacts Earth. However, by the time the solar wind reaches Earth, many of its properties have changed. Currently, our sun is behaving much more violently than scientists had anticipated. A recent announcement from researchers monitoring the solar cycle has confirmed that the sun's most active and dangerous phase, solar maximum, is now well underway, and the worst may still be ahead. Groundbreaking observations suggest that the number of sunspots on the sun's surface is rising much faster than expected, alarming researchers. Experts now claim that the rapid increase in sunspots is a concern, as it could lead to severe solar flares. NASA has predicted that the sun will be more active in 2025, and recent observations have raised worries about the impact of solar activity on Earth in the coming years. So, what have scientists discovered in their latest observations? Why are researchers so concerned about the rapid rise in sunspots? And what will powerful solar flares mean for Earth in 2025? Let's find out. Sunspots are areas on the sun's surface, called the photosphere, where the temperature is significantly lower than the surrounding regions. While the sun's surface temperature is typically around 5,500 degrees Celsius, sunspots can be as cool as 3,800 degrees Celsius. This cooler temperature makes them appear darker, though they still emit light. Sunspots are only dim compared to the sun's brightness. If a typical sunspot were removed from the sun and placed in the night sky, it would likely appear as bright as a full moon. The formation of sunspots is linked to the sun's complex and ever-changing magnetic field. The sun is made of hot plasma, and different parts of the sun rotate at varying speeds. The sun's equator rotates faster than its poles, causing its magnetic field lines to twist and stretch over time. When the magnetic field becomes highly concentrated in one area, it blocks the normal flow of hot plasma from rising to the sun's surface. This results in a region that cools compared to the rest of the sun. Since cooler areas emit less light, sunspots appear darker than the surrounding surface. These spots can last from a few days to several months and tend to form in cycles that correspond to the sun's magnetic activity. Are these sunspots a threat to Earth? Sunspots themselves are not dangerous, but they can lead to something much more powerful: solar flares. When the magnetic field around sunspots becomes too tangled or unstable, it can suddenly snap, releasing a massive burst of energy as a solar flare. This process is similar to an elastic band being wound until it finally breaks, releasing its stored energy all at once. Solar flares are classified by their intensity, with the most powerful ones being X-class flares. These are incredibly energetic and can release as much energy as billions of atomic bombs. As of October 4, 2024, Earth has been hit by 42 X-class solar flares this year. This is considerably worrying, as the strength of these solar flares has been increasing. Scientists believe we could see even more powerful solar flares in 2025. But why are solar flares becoming more intense? The increase in solar flares and sunspots is part of the sun's natural cycle. Approximately every 11 years, the sun's magnetic field completely flips, meaning the sun's north and south poles switch places. This solar cycle affects activity on the sun's surface, such as the number of sunspots, which rise and fall in a predictable pattern. There are two main phases of the solar cycle. 1. Solar minimum, when the sun has the fewest sunspots. 2. Solar maximum, when the sun has the most sunspots. One way to track the solar cycle is by counting the number of sunspots. The start of a solar cycle is marked by a solar minimum. Over time, solar activity and the number of sunspots increase, reaching a peak during the solar maximum. As the cycle progresses, activity decreases back to a solar minimum, and a new cycle begins. For instance, you can observe the increase in the number of sunspots during the solar maximum of 2001 compared to the weaker periods of 1996 or 2006. Nearly 100 years ago, Swiss astronomer Max Waldmeier left a trail of cosmic clues that scientists still follow to predict the sun's solar maximum. In 1935, Waldmeier discovered something fascinating about sunspot cycles. The faster the rise of the sunspot cycle, the stronger its intensity. He realized that a stronger cycle takes less time to reach its peak. This discovery, known as the Waldmeier effect, acts as a crystal ball for scientists, helping them estimate the strength of a sunspot cycle by observing its early development. Using this method, NASA scientists predicted that the next solar maximum would occur in 2025. However, recent data shows the sun is becoming more active than initially expected, leading to growing concerns. A diagram tracking sunspot numbers over the years shows the following. The black line represents the actual number of sunspots observed monthly using telescopes and satellites. Around 2019 to 2020, there was a sharp increase in sunspots, indicating that the sun is growing more active as the current cycle progresses. The purple line represents the smoothed sunspot numbers, which are averages taken over several months to highlight long-term trends. The red line shows the predicted number of sunspots for solar cycle 25 based on standard models. The shaded area around the red line represents the uncertainty in these predictions, reflecting the potential range of sunspot activity from highest to lowest. Recent observations reveal that the number of sunspots is rising faster than expected, which is concerning. Historically, a rapid increase in sunspot activity has been linked to stronger solar cycles. Because of this, scientists are more worried about the implications of solar cycle 25 for Earth. As we approach the peak of solar cycle 25, expected around 2025, the number of sunspots is anticipated to rise sharply, along with the likelihood of major solar storms. These storms can have significant consequences for Earth. When solar flares or coronal mass ejections, CMEs, reach Earth, they interact with the planet's magnetic field, causing geomagnetic storms. These storms can disrupt satellite communications, damage power grids, and interfere with GPS signals. Critical systems relied upon by many industries, from navigation to financial markets. To understand the potential risks, we can examine historical examples of solar events affecting Earth. The most famous is the Carrington event of 1859, the largest recorded geomagnetic storm in history. During this event, a massive CME struck Earth, causing auroras visible as far south as the Caribbean. Telegraph systems, the primary communication technology of the time, were severely impacted. Operators reported sparks flying from their equipment, and telegraph lines continued to transmit signals even after being disconnected from their power sources due to induced electric currents. If a similar event were to happen today, the impacts would be far more severe. Modern society is heavily dependent on technology, particularly satellites, power grids, and telecommunication systems. A storm of the Carrington event's magnitude could damage satellites, disrupt aviation systems, affect global communication networks, and cause widespread power outages. Given the rapid increase in sunspots during solar cycle 25, scientists are concerned that a similarly large solar storm could occur in the coming years. Although solar cycle 25 is not expected to be as extreme as some past cycles, the unexpectedly rapid rise in sunspot numbers suggests it could still produce significant solar storms. As we approach the cycle's peak in 2025, Governments and industries are closely monitoring space weather forecasts to mitigate risks posed by increased solar activity. Preparing for the possibility of major solar storms is essential to protect modern infrastructure from potentially devastating impacts. That's all for today. Stay tuned for more updates on the sun's rising activity and its implications for life on Earth.